Okay, now we proceed to reactions of alkyl halide. Okay, now for reactions of alkyl halide, okay, there are two types of reactions. Okay, the first one is nucleophilic substitution reaction. Second, elimination reaction. Okay, so note the difference between these two. Nucleophilic substitution means that it will substitute the halogen with the nucleophile, okay, to produce a product, whereas number two, elimination, means that it will eliminate hydrogen and halide, okay, hydrogen and hydrogen, okay, to produce the product. Okay, so now we look at the first reaction. Okay, the first reaction, nucleophilic substitution reaction. Okay, for this nucleophilic substitution reaction, okay, reaction number one, so I'll just nucleophilic, okay, substitution reaction. Okay, so the general reaction, okay, the general reaction is, so we write down, okay, do not confuse between general reaction with mechanism. Okay, mechanism is where there is an arrow attacked like this, and then attack again like this. Okay, so that one we call it mechanism. Okay, so this is general reaction. Okay, so for example, the starting material is always alkyl halide. Okay, it doesn't matter whether it is primary, secondary, or tertiary. So here, this is your alkyl halide. It will react with nucleophile. Okay, nucleophile. Nucleophile, we just put it as NuC. Okay, a nucleophile. Okay, if you don't want to put the electron, it doesn't matter. Okay, nucleophile. Okay, in the presence of solvent. Okay, solvent. The condition here, we need to add solvent, but again, it depends. Okay, so now circle, I'm using red color. Okay, so when you do the reaction, always use different color to differentiate. Okay, and then circle it means that is the one that will be removed. Okay, so here, circle this. Okay, circle. Okay, and it will be replaced by nucleophile. Okay, so the product form is RNuC, alkyl with the nucleophile. Okay, and that's it. So this is the reaction. Okay, so we look at example. Okay, we look at general reaction and its example. Okay, for example, okay, I'm just using a simple structure, simple example. Okay, okay, chloromethane. Okay, so the name here is chloromethane. Okay, remember you have to identify the IUPAC name and also the common name. So for the common name, this is methyl chloride. Okay, when react with water, water is one of the nucleophile. Okay, water, so we expand the structure. Okay, so now, okay, the solvent depends. Okay, so now circle Cl. Okay, for the nucleophile, we circle, sorry, okay, we circle the hydrogen. Okay, circle the hydrogen. Okay, so now it will which one that will attach to the R group? It is O. So now draw the remaining alkyl group attached. Okay, CH3, sorry, I'm using different color. So use, okay, CH3. Originally it is Cl, but it is no more Cl. Now it is OH. Okay, so this is your product. Product, and the byproduct here is the one that you remove, HCl. Okay, Cl. Okay, so this is the example of substitution. It substitute the nucleophile, substitute the substitute or replace the halogen. Okay, the nucleophile replace the hydrogen. Okay, so another example. Okay, another example here is reaction. Okay, bromobenzene. Okay, bromobenzene. Okay, bromobenzene react with methanol. Okay, methanol, CH3OH. Okay, bromobenzene react with methanol. Okay, if it is alcohol, which one that you need to remove? For alcohol, you need to remove H attached directly to O. Okay, it is not any H, it must be H attached to O. Okay, it will be like this. Okay, for alkyl halide, the halogen must be removed. Okay, so now you combine it, but which one? It must be attached to O. Okay, this one will attach to the alkyl. It's not C, it's not C. Okay, C has nothing to do with this reaction. Okay, so now, okay, draw the benzene again, but now it's no more Br, it is the one, look at the arrow here, it is O. And then this O has CH3 attached. Okay, that's it. So you already produce your product, and the byproduct here is HBr. Okay, HBr. Okay, and last one, we look at an example. Okay, so here again I'm using chloromethane. Okay, chloromethane. Okay, react with sodium cyanide. Okay, sodium cyanide. Okay, so through the arrow. Okay, so here remove Cl. Okay, for the NaCN, remove Na. So it will attach to Cn. So C, it's not N, it is specifically C. Okay, so now we draw the remaining alkyl, CH3 remain, no more Cl, so now it bonded to Cn, like this. Okay, and the byproduct is the one that you remove, NaCl. Okay, that's it. So that is what we call as nucleophilic substitution reaction. Okay, it looks simple, but this is what we call general reaction. If the question didn't ask for mechanism, so no need for you to do any mechanism reaction. Okay, so now moving on to the next one, nucleophilic. Okay, type of nucleophilic. Okay, type of nucleophilic is important. Okay, type of nucleophilic is important because this will identify the reaction. Okay, still under chapter reaction, nucleophilic substitution reaction, there are two types of nucleophilic substitution reaction. Okay, nucleophilic substitution reaction. Okay, as I mentioned earlier, nucleophilic substitution reaction, that one, the previous one, this is the general reaction. All of this, we call it general reaction. Okay, general reaction. There's no arrow attack on the carbon, anything, no. This arrow is just the to indicate on which one that will attach to the alkyl. It's not an arrow for mechanism. This one is just to label. Okay, so now nucleophilic substitution reaction, there are two types of reaction under this reaction, which we call it as SN2, SN1. Okay, S refers to substitution, N refers to nucleophilic. Okay, so 2 means the type. Okay, type of reaction. We have SN2 and SN1. Okay, I repeat, we have SN2 and SN1. So this has different mechanism. Okay, different mechanism. Okay, how do we identify whether the reaction undergo SN2 or SN1? It depends on the nucleophilic. Depends on nucleophile. The nucleophile. Okay, the second starting material. Okay, as I mentioned earlier, all of this. Okay, wait, I'm using different color or green color. Okay, for example, water. This is nucleophile. Okay, alcohol. Okay, this is methanol, nucleophile. Sodium cyanide, nucleophile. Okay, so all of these are nucleophile, but this nucleophile has different types. Okay, different categories. It falls under different categories. So we call it so the reaction, whether it undergoes SN2 or SN1, depends on the type of nucleophile. Okay, depends on the nucleophile. And for these reactions, okay, But before that, what does it mean by nucleophile? Okay, nucleophile is a chemical species. So I just put it chemical species that attacks carbon, alpha carbon. Okay, remember alpha carbon? Sorry, the wrong symbol. Alpha carbon. Remember alpha carbon? Alpha carbon is the one that attached directly or carbon bearing halogen group. Okay, carbon bearing halogen group. Carbon bearing halogen group. Okay, so that we call as nucleophile, a species that attack alpha carbon. Okay, so now type of nucleophile there are. So you draw a table. We have strong, moderate, and weak nucleophile. Weak. So this is nucleophile. So you draw a table. Okay, make sure you memorize this. Make sure you memorize this table, this type of nucleophile, because you are going to do the reaction, and you have to identify the type of nucleophile first before you can identify whether it is SN1, SN2. Okay, so for the halogen, okay, so first it will the nucleophile species that attack alpha carbon. Second, the requirement is that usually it is negative usually, but sometimes it can be neutral. Okay, neutral, depends. Okay, now strong nucleophile, I just highlight the most common nucleophile under strong, moderate, and weak. No need for you to memorize every nucleophile. Okay, but the one that I listed out here, at least you have the effort to memorize it. Okay, so strong. For halogen, the most reactive is iodine, right? So iodine, I negative. So this is strong nucleophile, I negative. So it can derive from I negative. It can derive from Ki, and Ai. Okay, whenever you look at the solvent, the compound Ki and Ai means that it will produce I negative. So usually in the question, it will not directly say iodide like this. It will give you the full compound. Okay, so from that full compound, you can identify it has I. Okay, like this. Okay, other than that, you have Cn. Okay, sorry, Cn, cyanide. Okay, Cn negative. Okay, Cn derives from, for example, metal cyanide lah, or for example, NaCN. Okay, sodium cyanide, KCN, again the same concept. Okay, sodium cyanide, potassium cyanide, it will derive the Cn. Okay, the negative charge of cyanide. Okay, this one is basic concept from chapter physical chemistry. Yeah. Okay, so now next, hydroxide. Okay, hydroxide ion. Hydroxide here is this OH. Okay, this is specifically hydroxide. This is a very strong nucleophile. Okay, strong nucleophile. This obtained from strong base. Strong base. Okay, for example, NaOH. Okay, KOH. Okay, other than that, CaOH2. Okay, so read through the physical chemistry, the type of strong base. It will list out which one is strong base. Okay, so all of these strong base will derive the OH negative. Okay, remember where does this OH comes from? It comes from strong base. So make sure you know the concept. Okay, the OH hydroxide comes from strong base. Okay, so now you have number 1, number 2, number 3. Okay, and then this strong nucleophile derived from alkoxide. Alkoxide, yeah, OR. Okay, OR. The negative is attached on the O. Okay, OR. This is alkoxide. Sorry. What happened? Okay, this is alkoxide. Alkoxide is the same thing. Okay, alkoxide is ether, yeah? Ether. Okay, it is not alcohol, it is ether. So alkoxide here means that, for example, let's say sodium ethoxide, for example, NaOCH3. NaOCH3. So this alkoxide, it will usually binds with metal. For example, Na, K, Mg, okay, as long as it is metal attached to OR, so we call it alkoxide. Okay, alkoxide. So for example like this, CH3, Mg, for example like this, right? So it will derive OCH3. It's not necessary CH3, yeah? As long as it is alkyl group attached. It can be O, CH2, CH3, or it can be O like this. Also can, as long as it is R group attached. Okay, here it can be alkyl, it can be aryl, it can be cycloalkyl. Okay, it is not necessarily CH3. CH3 is just the simplest structure for example. Okay, for example purpose only. Okay, so alkoxide. So remember these 4 strong nucleophile. Okay, mesti hafal. Okay, now moving on to the next one, moderate. Okay, moderate. So as I mentioned earlier, for halogen, moderate is Cl. Okay, and then we have Br. Okay, these two are moderate. Again, it is the same thing. It can derive from NaCl, can derive from KCl. Okay, as long as when you look at the here metal react, the combination of metal and the ionic halogen, so it can derive the halogen. Okay, so it will not directly acid when CH3, so it will state like this: show direction when methyl chloride react with NaBr. So dah blur. Br, what is Br? Is it strong nucleophile, weak nucleophile? NaBr, you haven't heard about this? Actually, NaBr, it will derive the Br. So now, Br falls under which categories? Br falls under moderate categories. So make sure you know the concept. Okay, and then ammonia, NH3. Look at this ammonia. There's no charge, so means that this is neutral. This is neutral. This is weak base. So you have to know whether it is under base or not. Okay, so now number 4, carbonyl compound. So it must be occurs under carbonyl group. Carbonyl group, how do you identify it? It has C double bond O, C, negative, and then this C attached to R. Okay, so this is carbonyl group, so it falls under moderate nucleophile. Sometimes they just put a molecular formula. So the molecular formula for carbonyl compound is RCOO. Whenever you look at COO like this, it is actually carbonyl group. So I just expand it so that you can see it clearly. Okay, so make sure you remember these 4 moderate nucleophile. It is very important for you to memorize the type of nucleophile. Okay, before we can proceed to the mechanism, or else you cannot do the mechanism because you don't know which one is strong, moderate, and weak. Okay, now moving on to the weak nucleophile. Okay, number 1. Sorry, why is it number 2? This one's supposed to be number 1, 2, 3. Sorry. Okay. For weak, so IClBr, so the weakest here is F. So F like this. F can be derived for any for example, HF, NAF, doesn't matter. The same goes for this one. As long as you can derive, oh, this one got F, so F means F negative like this. Okay, that is how you derive the negative charge. Okay, and then we have water, H2O. H2O, when you expand it, it will be like this, HOH. Okay, so water is neutral. Okay, it don't have any charge on it. And then alcohol, ROH. Okay, ROH. This one also neutral. So what is the difference between alcohol and alkoxy? Okay, alkoxy or ether alkoxide here. Alkoxide, as I mentioned earlier, it must be metal attached to the OR like this. For example, NaO CH2 CH3, for example. See, it's not alcohol. Alcohol means that the R, for example, CH3 must attach to OH. So this is alcohol. Okay, this is alcohol. So make sure you know the difference. Okay, if you don't know the difference, then we can proceed to the mechanism later. Okay, so make sure you know this nucleophile. Okay, at least you know the nucleophile first. Okay, so the reactions for SN1, SN2 reaction, as I mentioned, this one will determine whether the reaction undergoes SN1 or SN2 reaction. Okay, so now which one undergoes SN2 or SN1? Okay, SN1. Okay, wait. So SN1 or SN2. So we always focus on SN1. Okay, only occurs for primary and secondary alkyl halide. Okay, so make sure you know. Before anything, you have to classify first. Is this primary or is this secondary? The same goes for SN1. Okay, so now for SN1, the reaction only apply for secondary and tertiary RX. Okay, tertiary RX. So you should know this. Okay. Okay, so the reactivity, for the reactivity, which one is more reactive? Which one is more reactive for SN2 reaction? Okay, it is 2, 1. Okay, increase reactivity. If you cannot do it like this, so you can always use comma. So you just put increase reactivity. Reactivity for SN2 reactions. For SN1, okay, 2, okay, secondary, and then put tertiary. So the tertiary has the more tendency to undergo SN1 reaction, so it will increase reactivity. So you have to know the trend, because sometimes in the question it will ask you the trend on the reactivity, which one is more reactive towards SN2. Okay, SN2 or SN1 reaction. So you have to know this. Okay. Okay, so now for this one, okay, for this, make sure you know the reactions. Okay, let us recap on the first reaction, nucleophilic substitution reaction. This is the general mechanism. Okay, the general mechanism where you just replace the halogen with the nucleophile like this. Okay, and how do we identify the nucleophile? Whether it undergoes SN2 or SN1 reaction. S means substitution. Okay, N means nucleophile. Okay, substitution, nucleophilic substitution reaction under 2 or 1. It depends on the type of nucleophile. And depends on the class of nucleophile. So make sure you memorize this table. Okay, and memorize the reactivity. Remember, SN2 only applicable for primary and secondary alkyl halide. SN1 only applicable for secondary and tertiary alkyl halide. Okay, so that's it for this week lesson. For the mechanism, for a specific mechanism, we will cover it during our physical class. Thank you.